Welcome back, everyone. We're on day 32 now of our 50-day SAT Math Prep series on our journey to a 750 plus on the next SAT Math section. And today we're going to be doing more advanced math. And we're going to jump in right now. We're going to do about 5 of these problems. This is the first one. So we have this function f of x is equal to x minus 1 times x plus 3 times x minus 1. In the xy plane, when the graph of the function f, where y is equal to f of x, is shifted up 6 units, the resulting graph is defined by the function g. If the graph of y equals g of x is crosses through the point 4, comma b, where b is a constant, what is the value of b? Okay, so if y is equal to g of x is the result of shifting this up 6 units of f of x 6 units, so this is just plus 6. So we know that g of x is just equal to this over here. So we plug this in. G of x is equal to 4 minus 1 times 4 plus 3 times 4 minus 2. We're just plugging in this point over here and we're seeing what we get for b, plus 6. So over here we get 3 times 7 times 2 plus 6, which is equal to g of 4. And this would be g of 4 up here too. So g of 4 is equal to 42 plus 6, which is equal to 48, and that would be your answer. A hard problem, but once again, just know how to get to the answer the fastest way possible, and you should be good to go. Next problem. In the given equation, k is a constant. The equation has exactly one real solution. What is the minimum possible value of 4k? Okay, minimum possible value of 4k. K is a constant right here. I have a constant. It looks like a discriminant question to me. Remember, discriminant is b squared minus 4ac. And when there is exactly one real solution, you're going to have it equal to 0. And when it's two real solutions, you're going to be greater than, and then if it's no real solutions, it's less than. So, and that's greater than or equal to. Okay, so we have this equation up here, and we're going to distribute. So what we're going to do is to get rid of this square root, we're going to square it, and we have to do that to both sides. So we get k minus x is equal to, now we have to do 58 squared, which is 3,364 minus, and then it's times 2, so 116x, and then plus x squared. So now we could set everything equal to 0 by moving everything over and then having 0 on the other side. So we have x squared minus 115x plus 3,364 minus k is equal to 0. And then we use our discriminant formula. I'm going to write it down here again. B squared minus 4ac is equal to 0, since it's exactly one solution. And now we have to find our values. So we have a is equal to 1, b is equal to negative 115, and c is equal to, well, I'm going to write c down here since it's a longer value. C is equal to 3,364 minus k. So in our formula over here, we're going to have negative 115 squared minus 4ac. Sorry, c is minus that k too, is equal to 0. So we have 115 squared is equal to 1,000 or 13,225. The negative cancels out, minus, okay, then we have 4 times 3,364, which is going to give you 13,456, and then plus 4k is equal to 0. You move it over to the other side. So you have 4k is equal to 13,456 minus 13,225, and you get 4k is equal to found 231. And it's asking for the value of 4k, so you don't even have to solve for k. However, what it means by the minimum possible value here, we're not going to go in depth to that because I don't really see a point since you can only really get to one answer anyway. Is this over here. So you have the equation as we said at the beginning, k minus x, square root of that, minus 58 over x. This over here, so where 58 minus x is greater than 0. So you would pretty much you would solve for k, plug k back into the original equation right here, solve for x, and then make sure x is greater than 0 so that k value satisfies it. But once again, it's really a waste of time if there's only really one solution. But to make sure you can do it, we're not going to do it right now though. Okay. If x is a solution to the given equation, which of the following is a possible value of x plus 5? So when I see a large polynomial in the denominator like this, the first thing I think is factor. So we're going to do our ACB method. So a times c is 25, and then our b value is 10. What times what gets us 25, but when those same values are added, it gets us 10. That's going to be 5 times 5. So we can distribute this polynomial as x plus 5 and x plus 5, which is equal to 4. But then we could also simplify this again and write it as x plus 5 squared is equal to 4. And then when we could pretty much swap these if you're going to multiply and then divide. So it's going to be 1/4 is equal to x plus 5 squared. And we're going to take the square root of both sides. And we're going to get x plus 5 is equal to plus or minus the square root of 1 over the square root of 4. If you watched the content review video 21 or 22, we discussed how this is applicable. And the square root of 1 is what? 1. And the square root of 4 is what? We get 2. So plus or minus square root of 2 is equal to x plus 5. And it's asking for that value of x plus 5, a possible value. Sorry. So it's going to be 1/2, since it's positive or negative 1/2. A hard question, but just know, start by factoring. Don't start with anything too crazy, and you should be good to go. It's just picking the right method to solving the problem. There's a bunch of methods, but some are much faster than others, as you can see. Next problem, we have the function f of t is equal to 40,000 times 2 to the t over 790. Gives the number of bacteria in a population t minutes after an initial observation. How much time in minutes does it take for the number of bacteria in the population to double? Okay, so we're going to start with time 0. And at time 0, we have 40,000 times 2 to the 0, since 0 over 790 is 0. And we get 2 to the 0 is 1, so we get 40,000. And we need to know when it gets to 80,000. So what we're going to do is we're going to plug in 1, or sorry, not 1, 790. Because I see right here, if we plug in 790, we're going to get 790 over 790, which is 1. 2 to the power of 1 is 1. Then 1, or 2 to the power of 1 is 2, sorry. And then we get 2 times 40,000, which is double. So 40,000 times 2 to the 790 over 790 is equal to, so 2 to the 1 is 2. So we get 40,000 times 2 to the 1, which is 2, and then we get 80,000, which is double our first answer. So 790 is the amount of minutes it takes for the population of bacteria to double. Last question of the day, and this is going to be a graphing calculator question. The function f is defined by the given equation. For what value of x does f of x reach its minimum? Okay, we're looking for a minimum value. Whenever you see that, you can always use your graphing calculator to plug this into the y and trace. So we're going to do exactly that. F of x is equal to this equation over here. And I have it in over here. And we're going to graph. And we get this over here. If it appears too zoomed in, just press zoom and then zoom out, as you see here. But we're good, so we're going to hit trace, and then we're going to go down to minimum. And then we're going to go to the left of the minimum, eyeball it, enter, and then go to the right as it says, and then enter, and then guess, press enter again, and we get our minimum value as x equals 45 at y is equal to -1. So it says where does the minimum occur for what value of x? So we're looking at the x value, 45. Don't pick that -1. That -1 is a trap. Be careful with that because that's the y value. That's the value of the minimum, not where the minimum occurs. Be very careful with how these questions are worded. So we're going to stop there for today. I think we did a pretty good job with these questions. If you have any suggestions for future videos or questions on this one, please feel free to leave them in the comments. And I'm going to see you all on day 33 for some problem solving and data analysis questions. I'll see you all